Hello everyone. Okay, let's just wait for 5 more minutes. Once everyone will join, we will start the session. I hope you all have joined with laptop today. Hmm?
Yes, ma'am.
Good. Okay. Those who have not joined, make sure that in tomorrow's session you join this session with laptop or desktop. Okay. So if our session get wind up early today, I'll show you how you can install and configure this Cloudera image in your system. Okay. And if it will take time, then tomorrow we will see the same thing. Okay. So make sure where you join at around like these 3 4 lectures with laptop only. Okay, let's start today's session. So till now, Sunil sir had your session about DBMS. So today I'll give you a quick brief recap, I can say, about DBMS, then how we are moving towards big data. So today's session will also be a quite theoretical one, and maybe from tomorrow or day after tomorrow, means when your Hadoop will start, your HDFS will start, we are going to have the practical sessions as well. Okay. So please don't think that we are only having these theoretical sessions. We will have these practical sessions as well. But once this the okay, just a minute. Someone is asking for. Okay, sure. Actually, sir is not present today. Okay, so I'll check if I have the soft copy of that PDF. Okay, and if not, then I'll definitely provide it by tomorrow. Okay, Mahesh. And about today's PPT, I have already shared the study material with all of you via mail. You all must have received an email, which you have registered on FSP. Okay, you can check your email. There you will find a zip folder. Okay, please download it. All of you, please download it as it's on drive, and I have to clean up my drive early. So those who have received it, download that zip folder, extract it, use that study material. Okay. Okay. And one more thing, there is one request as well. When I'll start teaching, don't use this chat box. Instead, you can speak up because see, I will not get these pop-up sound of notification or chat. So there are chances that I'll miss your question. Okay. So if you are facing any difficulty, you have any query, you want to add up something, please speak up. Okay. So let's just start today's session. Okay, data, I am considering everyone knows these are the raw facts which you will process to get the meaningful information. Okay, now one thing I don't expect that everyone knows that we can divide data into different formats. See, we have different type of data. Okay, one you can say we have structured type of data. Another we have semi-structured data, and then we have unstructured type of data. Okay, Now, can anyone give me the example of structured type of data? What are the examples for structured type of data? Okay, the data which you have in a row and a column format, in the tabular format, that data will be considered as a structured data. That data which you can put up into the tables, which are in row and column format, that is structured data. Okay, then we came across with the semi-structured data. Okay, the data which is not completely structured like in a row and column format, but somehow they are structured. If you have studied these HTML, CSS or log files, there you will see tags. So they are somehow structured, not completely, but they have they are somehow structured in the tags. Okay, so that type of file or data like HTML, CSS, log files, these all will considered into the semi-structured type of data. Okay, then we have unstructured type of data. Now, I want answers from you. What are the examples of unstructured type of data?
Text file, ma'am.
Yes, text file, audio file, video file, images. These are unstructured type of data. Okay, so I see earlier when you will see we have data, mainly if we'll talk about, these were of structured type of data which we can store into tables in row and column format. But now if you will see, we have a lot amount of unstructured data as well, right? We have those GIFs, we have images, we have this videos, audios, right? So this variety changes. Now let me just erase it and then give me a minute, okay? Another thing is, since you have studied DBMS, okay, you had a brief description about DBMS. See, when you can say on early stages, when people used to store data, what were the means? Either they store data onto the stones, okay, or on leaves. If you talk about early ages, stones or leaves, they use these things to store the data. Okay, there they write the data either by rock or by coal. Then if we in later ages, you can say we had another means, like we had the options of file system. Okay, you can say before 1950. Okay, we had file system. And file system says that we store data in notepads like file. Okay, notepad or Excel sheet, and using any program, whether it's a C program, Java program, means some program, maybe it is written in COBOL or something, say any other programming language. Okay, we use those programs to access the data from these notepad file or something like. Okay. Now, if we will talk about these stones and leaves, see, there were disadvantages storing data there, right? And after that, if I'll forget about this file system, you remember we had those Bahi Khata system where people store data onto the register, and on Diwali or maybe on the year end, they just calculated what is the profit for this year and what's the loss for this year. Like this, they counted. Right. So from stones and leaves, we moved to the Bahi Khata system. Okay, from Bahi Khata system, when computer came into existence, we had those file system. Okay, in file system, people store data in notepad file, text file, and they access the data using the programs. Okay, now there were disadvantages of every one of them. See, if you will store data on stones and leaves, somehow they will you will lose the data. Then you have those paper and pen, those registers in which you store the data. Okay, after some time you will see that those are getting the pages are getting rotten. Okay, so you will lose the data. Even if you want to analyze a large amount of data, yearly data, okay, there are chances that there will be errors there when you are finding out the sale, profit, everything, whatever you are analyzing, there could be error. Then computer came into existence, okay, which can give me a minute, which can solve your problem, and you can just check, you can analyze the data, you can add up, or you whatever calculation you want to perform, it can perform very quickly. But the problem with file system is, if you want to share the file, okay, then suppose you have some data, you have a university data where you have faculty data, faculty table is there, faculty notepad file is there. You want to share the faculty names with the students. Either you have to share the complete file with the student, or you will create another file where faculty name will be there and that you will share with the student. Two options you have. If you will share the complete file of faculty with the student, the faculty privacy will be revealed. If you will create another file where you will store faculty name only, then there will be redundancy, means data repetition will be there. And every time you have to do the same thing so that someone's privacy should not revealed. Okay. And many other reasons were there, like security reasons were there. So file system also failed. After that, RDBMS came into picture. DBMS, I can say DBMS, not RDBMS, DBMS came into picture. Okay, and in DBMS, we will, you can see that different type of DBMS were there. Sunil sir must have told you about this: hierarchical, network, flat. Okay, so all those have some problems, like they have to write in some programming language which is quite difficult and complex, and when you are accessing data, that is difficult. Then in around 1970, relational database management system came into picture, which EF Cod. Okay, who's the father of, you can say, this relational database? He brought in around 1970 this relational database management system, which says that you can store the data into the row and column format, into the tabular format, where accessing is easy, where security is there. Okay, where if you are updating or deleting anything, that will be updated simultaneously, means if you are making changes in one table which is related to another table, so the same changes will be reflected to the another table. It should not be like in one table changes is made but another table still the old record exists. Okay, so all those things were handled when relational database management system came into existence. So it resolved the problem at that time. But later on, when the data comes with different variety, which we have just seen, structured, semi-structured, and unstructured, but relational database management system were only dealing with the structured
Ma'am,
type
your
of
screen
data.
is not visible.
My screen is not visible. Just give me a minute. Okay. I hope it's visible now.
Yes, ma'am.
So till now, whatever I have told, did you understand or not? Anywhere you have missed
Yes, ma'am.
anything? I hope everything's clear till now.
Yes, ma'am.
Okay, good. See, uh, if I can give recap, this was the recap that in the early ages, we have stones and leaves where we store data. Then we came across with this Bahi Khata system where we have those diaries and registers where we store, where we write the data. Then we came across with the file system in the computer. Then we came across with the RDBMS. Okay, and RDBMS solved all those problems at that time, but it was only dealing with structured type of data and with a small amount of data. Later on, data size increases because now, whenever you wake up, first thing What you do? This is the question from everyone. What's the first thing you do in the morning?
Check WhatsApp.
Check our mobile
WhatsApp,
phone.
check Instagram, check mobile phone, turn off the clock, check news, right? So everyone just have those digital thing in their hand. Okay, where, see, if you will if you are checking data, there are chances that someone has sent some message, maybe some reels or videos or memes. Okay, there must be some news. Maybe if you are studying in colleges or university, you are getting mails from there. Okay, or you are getting some notifications. Maybe you have installed some app, so you are getting some notification. So all this information, these digitally information, they are rapidly, they are at a very fast rate. This data is increasing. Okay, and in a different format. Someone is sharing you the text message, someone is sharing these videos or memes or gifs. These are in different formats and at a very high rate. Everyone, the moment they wake up, they check their phone. Okay, so data is increasing at a very high rate. It's vast, voluminous, and in different variety, which RDBMS cannot handle, because RDBMS can handle structured data and small amount of data. Real time of data it cannot handle. Okay. So then we talk about this big data. We will formally see its definition later on, but how from RDBMS, how from all these systems we are moving towards big data, and what are the solutions we have for big data, that we will talk about later. But I just want to narrow it down, that what all systems we have earlier and how we are moving towards big data. Okay. I hope till now I'm clear to everyone. Okay. Now let's see some of the characteristics of structured data. So structured data says that it has clearly defined field organization in records. Okay, so when you were studying DBMS, it must have told to you that we have table which is in row and column format, where rows are known as records and attribute. These columns are known as the attributes. Okay, so structured data, when we talk about structured data, it has clear schema which is organized in records. Mean these rows, records, we are talking about record, these rows, in these rows it is arranged. Now, another thing, schema on right. And when we talk about big data, it is coming from different sources. So we don't have any schema for it, for unstructured type of data. Okay, we have to deal with these unstructured type of data as well. Now, schema on write, that requires data be validated against a schema before it can be written onto a disk. When you are storing the data onto the disk, okay, means you have some data and you are storing it onto a disk. Before storing it into a disk, it will validate with a schema. What is schema? Means when you define the table. If you have studied SQL, first thing you define the schema. In the schema, you will tell what's the table name, what are the different attributes present in it, and what are the data types for it, what are the constant for it. All those things you define. That is what basically you are defining a schema. Okay, now inside, now you have created a schema. Now if you are storing some data, you have only created 5 columns, but you are when dumping the data, it contains only 4 columns or maybe 6 columns. So it will give you error. Okay, suppose you have set a constant that it needs to be a primary key or it should not be null, but you are dumping a null value or you are dumping a duplicate value, such like that. It will give you an error. It will not allow you to store the data. So whenever you are dumping the data, whenever you are storing the data onto the disk, firstly, it will validate. whether it matches with the schema or not. Whatever value you are entering, whether it matches with the schema or not. See, if this start working when we deal with the big data, means we talk about terabytes, zettabyte of data. If this thing will happen, then what will be the case? If this thing will happen, our process will slow down because we don't have any proper schema. We are getting data from different sources in different format. We don't, if we will start, if we'll create the schema for it and start dumping the data, maybe at initial position only it will get some error and our rest of the data will not get stored onto the our process will stop or it will get slowed down. Okay, so this is the, you can say, disadvantage when we talk about big data. Another thing, a design to get data from the disk and load the data into the memory to be processed by application. Basically what happened, we have CPU. Okay, then we have RAM, and this is RAM. Okay, give me a minute. Consider this R as a RAM. Okay. Then we have hard disk. Don't judge my drawings, just try to understand it. Okay, CPU, if I want to do any processing, CPU will do it in RAM, right? And RAM is does RAM stores data permanently or temporarily? RAM stores temporarily. Okay, so what RAM will do? RAM will get the data from hard disk, right? Now see, RAM size is small. We have small size of RAM, and hard disk is, you can say, it's a it's have a larger size as compared to RAM. Okay, now we have large amount of data. When we transfer some data from hard disk to RAM or RAM to hard disk, there will be a speed issue. There will be a processing issue because we have large amount of data and memory size, one is big and one is small. Okay, so transferring the data is inefficient. When we are, see, in with small amount of data, it will work fine. But when we have big data, when we are talking about big data, then this is, you can say, this is the disadvantage. Okay, RDBMS cannot handle because it is getting the data from hard disk, then it is processing in RAM. Okay, and then giving you the output. So because of the size, different size, it will give you issues when we will deal with the big data. Another thing, relational and warehouse database system that often read data in 8K or 16K block sizes. So when we talk about relational database management system, if you want to read some data, it will read the data in small block sizes. So either it will be 8K or it will be 16K. But when we have big data, if we will read in small chunks, then again our process will be very small. We need to analyze, we need to process, we need to do many things with our data. If it's very, if we are reading in very small chunks, then it's a disadvantage. Okay, so these are all the disadvantages, you can say, of RDBMS that we need to overcome. For this, we have different solutions. Okay, clear everyone?
Yes, ma'am.
Okay, wherever you feel any difficulty, just stop me there. Okay, another thing. A step towards big data. So organization, see, when we talk about whether it's a IT organization, government sector or health sector or bank sector, any organization, they contain large volume of information, whether it's of employees, whether it's of past employees, current employees, or the products, or they have any schemes. Okay, whatever they have, like hospital, they will contain a large amount of information. Now, in a number of traditional environment, data scientists spend 80% of their time looking for the right data and 20% of the time doing analytics. Actually, more percentage these data scientists needs to give on analytics part. But most of the time they are devoting to looking for the right data, because since they are getting data from different sources, firstly they need to clean it, they have to map it to something, they have to process it, then only they can analyze something, right? Now this whole process is taking a lot of time, that most of the scientists getting less time for analysis part. Okay. So all these things we need to handle that. Firstly, there should be one source where you can actually store the data, because RDBMS say I can only store structured data and small amount of data. So there should be some platform where you can store the data. Okay, and if you are processing it, it should be a speedy process. It should not be a slow process, because when we talk about RDBMS, it is reading only in 8K or 16K block sizes. There is a size issue in RAM and hard disk. Okay, so transferring the data is also very difficult. So this should be reduced so that data scientists can devote more time towards analytics part. Okay, now see, every one of you, I hope every one of you use social media. Yes or no? Social media, Facebook, Instagram, Twitter, every one of you use that, right? Netflix. Netflix is not a social media, but I hope everyone uses it. Right. Okay.
Yes, ma'am.
So give me one example. Every one of you needs to give one example how you generate data there. How you are the source, how you generate data there. Firstly, Abhishek will tell. Which social media platform you use, Abhishek?
Ma'am, Insta.
Instagram. And how you generate data over there?
Ma'am, like the post.
Liking the post. Harshita, what about you?
Ma'am, WhatsApp.
WhatsApp. Yes. How?
By texting the messages.
Okay. Mahesh.
Ma'am, LinkedIn by posting.
Okay. Pavan. Neha, please don't use these comments, because see, I already told you that when I'm going on with the session, I hardly see the chat box. I hardly able to see the chat box. You can speak up. Okay, Ansh, what about you? So no one's here who create reels, who is the create reels or something like that. Only comments and like person are there who just like someone's meme or post. Okay, I hope you all got the point. So I'm sharing my screen again. Okay, so these are some of the example on social media, what type of information people you can say upload, like what you are doing, like people upload that where they are going, in where actually they are and where they are visiting, where they work, all those things people upload. If they are going on a vacation, maybe by flight, so they upload it, everything. Even if they are thinking, like if they are feeling sad or they are emotional or happy, or if maybe someone's birthday is there, okay, so their feelings they show there, okay, by writing post or comment, by adding post and all those things, by sharing some good or bad post, okay. And whatever you like, your liking habits, your driving patterns, purchasing pattern. Okay, if you have liked something, that will be visible onto your page. Okay, if you have recently bought something. Okay, so people have habits that they upload the status for that. Maybe it's a WhatsApp status or a Facebook status or an Instagram post. Now, these type of information people upload. Another thing, what can you correlate? After correlating this data, what you can get from this information, from all these posts, what all you can get. Like if you will talk about health, you can you can find out whether a person is an alcoholic or not. If some person is there who's sharing some type of such type of memes, or maybe they are uploading the post, or maybe they are going to a place, to a bar or something like that, and showing the photo with a you can say with champagne or beer, so you can identify whether a person is an alcoholic or not. This type of information can be predicted. Money related information, like how you are spending money. Okay, if you are like if you are uploading some status, okay, or you are liking maybe a cars, maybe a brand of car, you are liking some post, so this can be identified where you are spending money. Maybe you are purchasing a home appliance, or you are purchasing some clothes. So this type of, like, if you will, you will have post like this, those type of images. When once you have buy something, those that website will start posting the image, such type of images, so that can be identified. Personal information, whether you are a safe driver, whom you are going to vote for. Okay, because you will see on social media different pages will be there. Political pages will also be there. If you are liking some political pages and you are disliking some political pages, so you, it can be identified that that particular person is going to vote for such particular party. Okay, then infrastructure related, like whether it's a good place to buy a store or a business. If you're seeing that that there are a lot of people visiting such places, okay, so it's a good place where you can open some store, you can open your business. Okay, so all those things, by correlating the information which you have uploaded, which you have shared, which you have liked, all those information can be correlated together to find out something. Okay, these are not only options, but there are others as well, which you can find out about the person. Okay, for your benefit or the person benefit. Now, let's see formally what's the definition of this big data. Give me a minute. Now, big data basically is, putting simply, big data is larger, more complex data sets, especially from new data sources. Okay, so it's larger means it's voluminous, complex, because data is not only of structure type. We have semi-structured, we have unstructured data type as well. Okay, and especially from new data sources. Can anyone give me the example of one new data source from where data is getting generated? You all use smart devices.
Ma'am, IoT and sensors.
Yes, correct. Any other example? How many of you use smartwatch? Hmm? No one. No one have smartwatch. Smartphone you have?
Yes, ma'am.
Smart AC, smart home, smart TV. These are all the new sources, you can say, which are generating data. These data set are so voluminous that traditional data processing software just can't manage them. Traditional data processing software is basically your relational database management system. It cannot handle this large voluminous data. Okay, so according to you, is RDBMS is a problem here? Was it not created correctly? Yes or no? Was RDBMS created incorrectly? There was some problem with RDBMS. What is your opinion on that? See, RDBMS was created at that time by taking consideration that problem at that time. Okay, we have mainly structured type of data, and we do not have this large amount of data. So for that time, RDBMS was good. But if we talk about today's state, if we talking about big data, we cannot take the help of RDBMS to store and process data. Okay. Now, what are the motives behind big data? So data has evolved, you can say, around 10 years. Okay. So we are in 2023, you can say maybe around 2011 or 2012. Okay. From last 10 years, just give me a minute. Okay, so from last 10 years, data has evolved as never before. Because of these, you can say this, because everyone have now smartphones. Everyone logged into their email IDs to these social media sites. You can say social media sites are the biggest source for this for these big data. Or you can say these stores like Amazon, like Flipkart, Jabong, Myntra, you can say this Netflix. These are also creating data and in a very large amount. So recently these sources has increased, so data size has increased. Now, the question arises here is, why are organizations interested in big data? Okay, data is generated. Then why are organizations are interested in that? Why are Amazon interested in that? Why is Netflix interested in that? Why is eBay is interested in that? Why Facebook, why Google is interested in big data? What is the reason behind it? Okay. Reason is for their organization benefit. Because if Amazon will analyze the data, what type of data it can analyze? It can analyze a person's purchasing pattern. It can analyze, like if you will talk about Facebook, it can analyze the people's choices. We will talk about Facebook. And if we talk about Netflix, it can analyze what kind of movie or what kind of web series people are liking, so that they can increase their organization benefit. Okay, so all those things they are interested in. First, they will analyze people's data, then only they can interpret some result from it to get the benefit from that data. Okay, for organization benefit, for organization's profit, for profit making. And it's not only the benefit for the organization. If you will talk about government sector, they will analyze people's data maybe for people's benefit, those citizens benefit. Okay, so that data needs to be analyzed. If you want to analyze the data, you have to handle it. So the second question is, why there is sudden rush and ramping up of infrastructure to handle big data? First question is, why they are interested? Because they need to analyze it for their benefit and for citizens benefit, so that they can provide you good services. Okay, if you will not like any organization services, like if you will not like Amazon services, you will stop ordering items or products from it. Okay, so it's for citizens benefit and for organization benefit. Now they need to analyze the data. Second question, why there is sudden rush and ramping up of an infrastructure to handle big data? Okay, we need to analyze it, but where we can analyze this? First, we need to store the data. We don't have any means where we can store such type of data, because data is of different variety and it is coming at a very high rate with you can say in a vast volume. So where to store it? Okay, let's say we have used some means where we can store the data. Now how to process it? How to analyze it? This is required. So this answers your second question. So this is required. What is the mean to store the data? What are the means to process the data? That is required. Okay. Now, I hope till now I'm clear. If you have any doubt till now, please ask. Okay, so today's last topic is we will take one of the use case as Facebook. Okay, before I'll give you any example that how Facebook uses big data, can anyone give me any example how Facebook uses big data? One example is given, I guess, over here as well. No. Okay, who can give me example how Facebook uses your data? How Facebook uses big data?
To show relative post.
Yes, they show relative post. And they use it in by different means. They will track your cookies. They will have now they have added this facial recognition feature. If you remember, tag suggestions they will give you. They will analyze your likes, your dislikes. Okay, so how they track cookies means suppose you have how they see how they do it. Suppose you have logged in onto Facebook, and on the another tab you are searching something. Maybe you are searching Amazon or Myntra. Another time you will go to your Facebook page, you will scroll down, you will see similar type of item which you have just visited onto the another tab. What it has done, it has tracked your cookies and now giving you the similar type of post which you have seen in the different one. Maybe you have searched news, you have seen any political page. They will start giving you those type of ads in your Facebook page. Another thing, if you will post some images, now if you have recently used it, I guess it's around 4 or 5 years back or maybe more than that, they have added a new feature. If you will post any image onto the Facebook, it will just create a bounding box over to every image. Suppose it's a group picture, so it will create a bounding box to every face, and it will give you suggestion that this is that person, you can tag to that particular person. Like this it will give you start giving you suggestion. So what it is doing, it is basically recognizing the faces from different profiles, and then it is see how correctly it gives you suggestion that it is maybe it's your some friend, correct name it will give you that you can tag to such and such person. How it is giving, its facial recognition system is so good, even you have clicked the picture in a market and there are some people behind it, it will track. If they use Facebook, they can track them as well. So even such people have filed a case against Facebook that they are revealing their privacy, because those people were unaware of that. Still they are being captured onto the photo. Okay, and also they will analyze, Facebook will analyze your likes and dislikes. If you have liked some particular page, if you have disliked some page, if you are sharing some memes, or maybe some pages you are sharing, they will analyze it. Now Facebook has also included this friendversary and happy birthday post. 10 years friendversary they will create. So what type of, see, in they will give you a video and people start liking it. Why see, many people at that time they have shared those happy anniversary, happy friendversary and birthday videos as well. What they will do, they will search some mostly liked pictures of you, they will add them in a video with some slow and a light music and a retro music. They will add that music and people like it, people will share it, people will see how what they have done, they have actually increased their users using that. They will remind you when is your friend's birthday, so people don't leave Facebook easily. Okay. And if you have heard about one case, Cambridge Analytica, Trump case, remember how Trump won the election? See, if you all have, see how many of you have used Facebook before? Just raise your hand. How many of you have raised Facebook? I hope everyone, one or the other time, everyone have used Facebook. See, there was a case that how Trump won the election. Okay, actually, if you have used Facebook, you must have seen there are some questionnaire game like questionnaire that which will give you the like a personality test quiz on Facebook. Okay, so everyone, if they have used Facebook, everyone has used those games. That every time they will give you some other type of personality quiz where you will answer around 5 or 10 questions, and then it will tell you about your personality. Okay, so one organization, they have created a quiz like that, and they have posted onto the Facebook. So many people, those person who were using Facebook, they have attempted that quiz, and they have never read their privacy, their terms and condition. And their terms and conditions say that they will get your information along with your friends, whatever contacts you have in your phone or in your device you are using, whatever friends you have, their information also they will take. Okay, so they are in terms and condition, they have written that, and people just clicked it on and they have played that quiz. So those person who have not played that quiz, that personality test, those information was also being taken by that organization. Now, Trump organization came to know about this type of quiz, that particular researcher have the information about so many people. Let's say half of the country, or maybe 70 or the 80% country information they have. Now, having that critical information, by knowing what are the person's opinion, person likes and dislikes, you can manipulate them easily, right? So they used that information to manipulate the citizens, and they won the election. Later, when the case was filed and everything was held, Facebook said, okay, whenever we are sharing the information with a third party, we will notify the person. But still it is not stopped. Okay, they will notify the person that they are sharing the information. Okay, so this is how people can use it for their benefit, organization can use it for their benefit or the people's benefit. So this is how they uses that data, that big data, for to win the election. That was the Cambridge Analytica case. So it can be for the positive purpose, it can be for the negative purpose. For both purpose, it can be done. Analysis can be done for both purposes. Okay, so that is why the case was filed. So don't get it in a wrong way that you are studying big data and you are going to analyze someone's information, personal information. No. Okay. So I hope till now I'm clear to everyone. If someone has not used Facebook, I can take the help of, I can take the another example like Netflix. If you have used it, if someone is getting if someone is not getting this topic, I can take another example and will make you understand. Any doubt, anyone?
No, ma'am.
Okay. Do you want any other example? Or the topic is clear?
Clear.
Okay, then we will meet tomorrow. We will proceed with its basic. We will move towards Hadoop, and once we will reach to the Hadoop, then we will see the installation and configuration part. Okay.
Okay, ma'am.
Okay, then. Bye bye. Then take care. Let's meet tomorrow at the same time.